Reverse list. You might be wondering how to reverse a list in Python, and you've come to the right place. Turns out it's really easy to do, and there's more than one way to do it. Let's just jump in real quick. And if you want to actually read the article on this that you see displayed right here, just look for the link in the description, and this video should actually be embedded on this page by the time you're actually viewing the video. We're going to run this from a terminal here, and let's see. I'm basically just going to read what the article says and then demonstrate it over here. So reversing a list is a relatively common operation in Python. This is a common interview question and a common test question. It comes up in the real world sometimes as well. We can use this as an example list, and our goal is to reverse the list to look like this. So that's a pretty simple, basic example. There are a number of different ways to reverse a list in Python. We're going to cover a few of these different methods here. Note the difference between reverse and reversed. So two different functions, both can be used and are demonstrated below. So we're going to demonstrate these here. We're also going to actually demonstrate list slicing and some other things. So, one of the methods is the reverse function. This function is part of every list object. It provides you with an in-place reversal, meaning that it modifies the original list. It just moves everything around in place. This will use less memory because it doesn't create another copy of the same list. The function doesn't return a new list, because it doesn't create a second copy, and it doesn't return a new list. It just edits the one you're working on in place. If you check the list after having called reverse, you'll notice that it has been changed. This is probably the most straightforward Pythonic way of doing things. So this is the way you should do it. You could pretty much just take this example. This is your answer right here. We're going to demonstrate this. Then we're going to show you some other ways that you might find a use case for, but it's just good to know about. Maybe someone just asks you to find a different way to do this on a test or something. But let's give this a shot. Python. So this is Python 2. We also have Python, let's just run Python 3. And there we go. So we're going to create our first list, assign it to a variable, paste that in right there, and there we go. We've got that variable. Let's just print it out. The example doesn't show us printing it beforehand, but if you just type the name of the list variable, it'll print it out for you. We're just using the Python interpreter directly. We're not actually creating a script or anything, because this is all throwaway code, and it doesn't really matter anyway. So we're going to say list1 reverse, list1 dot reverse, and now we're going to type list again just to see what it looks like, and boom, there you go. The list is in reverse order, and that's it. It's as simple as that. Pretty much one single line. You take your list object and call the reverse function, which is a member of your list object, and it reverses it for you. Then you can print the output just to verify that it was done, but this is pretty much it. Just these few characters right here. One little line of code will reverse your list for you. So that's pretty easy. Let's keep on going. Did I mentioned reverse and reversed are different. Yeah, I have a little bit on that down here, so we'll get to that. So, and I wrote this article a while back, so if I don't get to that, I'll cover it in the video anyways. So the other way to do it, and I actually kind of like this way, even though it's not, I guess, the right way to do it. Well, there's no real right way, but there's a method for it that does it for you, and that's probably what you should use. It probably does a better job, even though I can't see it being much more simple than this. Maybe using a slice uses up more memory, I'm not sure. But yeah, list slicing is another way to do it. This is another excellent way of reversing a list in Python. It's a really neat way of doing things. So yeah, like I said here, this is my favorite method and it's super easy. So we already have this list variable defined. You know what? Let's overwrite it just to be sure, because we've already reversed the list. So let's see. Can we overwrite this from the, yeah, there we go. List 1, boom, there we go. There's our list in order that we haven't reversed yet. And do the same thing, but we're going to take a slice. So we're going to take a slice of the same list. And there we go. It's in reverse. So basically, you don't even have to call a method to reverse it in place or anything. And it's not reversing it in place. That's worth noting. But this takes a slice of the original list, and instead of basically between these colons, you would put your starting point of the slice and your ending point of the slice, and then whether you want to go like how many steps you want to go if you want to skip elements in the list. So put a -1, so we're going back. We're going instead of going forward, we're going backwards by 1 step each time. And we basically, this first number here is just the first and second numbers are missing. So basically the parameters for a slice, you basically just put 3 numbers separated by 2 colons. Since we don't have a beginning and end number, it just takes the entire list. So we take the entire list and walk backwards through it, which basically gives you the reverse of your list right here. Now, if we type out list, we want to just output what's inside list, it's in order. So that slice was just a temporary slice. We didn't assign it to a variable or anything. Not sure exactly how much memory it uses up to do that, but yeah, it does not edit it in place. We could have saved it to a variable. Let's just do that just for fun. List 2 equals, and list 2. There we go. We saved the slice to a new list. Now we can output list 1, and we can even say list 1 equals 1, 2, 3. Let's just make something like that. So now if we say list 1 looks like this, list 2 is a whole new list. We're not like just it's not like taking a window of the first list and printing it in reverse. We actually created a new list in reverse when we saved that slice to a new variable. If you're still watching this video at this point, you're probably interested enough in lists and watching this type of thing that you're probably not too bored by what I'm doing. So I'm going to keep on going. Let's see here. Yeah, so some people say this method isn't the most Pythonic way of doing things. Personally, this is my favorite, but that is probably because I'm coming from a Perl background. I like neat little shortcuts and stuff, and syntactical sugar. I guess you would call that syntactical sugar, but yeah, I like nice little things like that, and I think this just looks really nice, and it's a slick way to do things. I like it better than just calling a function, although, you know, remembering the syntax for this, which you still should remember, even if you use the reverse function, which is, you know, using a function with the name reverse makes good sense, and that's probably the most straightforward way to do it. You still really kind of have to know how this syntax works for reading other people's code, and there are situations where you do need to take slices of lists, maybe not for reversing a list, but for other things. So it's just good to know how it works. It's a thing you need to know how to do. But anyways, yeah, it looks like I put a little note down here about the new copy. Yeah, so using this method, a new copy is created. This is a shallow copy, meaning that even though it creates a new list, the values reference the old values. A new object is created, but the data points to the original data. This is kind of like having a new view of the same data. The original is still left in place in order. We'll cover the idea of this down below, I guess. This method, all right, so it does use more memory. I wrote this article probably about a year ago. So anyways, uses more memory. It creates a new copy of the list, or a new view. Basically, the slice is a new list pointing to the old data. But if you overwrite the original list, it's not going to affect the new data. Then it starts copying the data to a new directory. But so long as you're not editing the new list or the old list, it basically references the same data until you change that data. That's my understanding on how that works. So we already talked about slicing to syntax, but it's good to see it right here. So as I mentioned above, slicing syntax works like this. You have a start, a stop, and a step. And when you're reversing a list, you want your step to go backwards. So if you were to set step to 1, you'll step through each element one at a time. Set it to 2, you're doing every other element. And 3, it's every third element or whatever. So and if you make that negative, you're stepping through the list in reverse order. And if you leave out the start, you start at the beginning. Leave out the stop, you stop at the end. Leave both of them out, you do the entire list. And the negative just does it in reverse. So, yep, that's pretty much what I typed out here. That's basically how it works. So let's get sidetracked a little bit and talk about lists and shallow copies. And I should probably let's move this document over here a little bit. So actually, I'm going to move this over so we can read this. All right, so we're probably getting a little off track here, but here's another example. This shows us saving a reverse slice to a new list. We can, so we already did that. I already showed an example of that, but we're going to do it again. We can then modify the contents of this new list without the first list being touched. This works fine as long as the items in the list are only simple values. So yeah, I guess the one thing that could come up if you put actual objects in your list, it might behave a little bit differently. But let's do this. This is kind of the same thing that we already did, but let's see. List 1 is still in order, right? Nope, no, I overwrote. That's right, I overwrote it. So we should probably define list 1 again, which is fine. We'll get a fresh copy of list 1. I'm just gonna grab that from here so I don't have to type this out. Copy that, paste it in here. And there we go. There's list 1 in order. So we can pretty much save this to a new list. Before I had saved it to list 2. Let's save it to test like they show in the example here. So save that there and say test. And test is list 1 in reverse order. So that's all fine and great and everything. And this, I guess, is pretty much the exact same example I just showed you. That, there we go. There it is in order. So you see the original's not changed. Now let's alter this new test list. So we're going to write a value to test at position 5. So we're gonna add the value 77 in there. So hit enter and say, now we say test, and notice that we have the value 77 written right in here. So we overwrote a value in our list, in our reversed list. So yeah, our reversed list, we replaced the number 4 with 77. Now if you look at list 1, nothing's changed here. So we can edit the data in our second list. We could pretty much do the same thing with list 1 too. Should I do? Yeah, you know what? I'm going to do that. So let's say if we did list 1, say position 3 equals 88. Let's just do that. So list 1 is now changed. We have an 88 in here, and we'll also see that test is not changed. So that's kind of none of this should be incredibly surprising, but that's how that works. So let's take this a step further and see what happens when we have a nested list. Assigning values to elements in the nested list from a new reversed list will modify the original as well. Basically, objects in the list are just pointers referencing the object. So both the new and the old list are referencing the same nested list. Here's an example that shows exactly that. So this is where things get a little bit more interesting. So we're gonna copy this, paste it here. All right. So there, we've defined a list called A, and we'll also define one called B. That's same list in order, or in reverse order. So there we go. Yep. A looks like this. B looks like this. So you'll see A is a list where one of the elements is a nested list right here. So that's a list within a list. And B is the same thing, has a nested list. What else? So it actually didn't reverse the nest. The elements in the nested list did not get reversed. That's worth noting. However, put the nested list at the end, so basically reversed the outer list and not the inner nested list. So that's an interesting thing to note. Now let's say if we're going to change B, and yes, let's just print them both out just to see. A, B. All right, so this only edits A, or rather only edits B. So what else do we want to do? What if we then we're now going to edit the nested list within B. So let's paste that in there. Now we're not editing. See, this first time we edited just one of the elements within B. Now we're editing one of the values inside an element within the nested list. So there we go. And yeah, let's just print them both out. Let's print A, and you'll notice A was changed, as was B. So notice the nested list was changed in both of these. So yeah, that's basically because the nested list is like a third separate list, and both of these lists, they're basically the last element in the list named A is just a pointer to a new list that doesn't have a name, and the first element in the list B is just a pointer to that same same third list. So it's the same list that we're editing when we edit a nested list, which is kind of interesting. But let's say if we edit B again, I don't know why I edited it. There's not much point in doing this, but we already know. Oh, you know what? Yeah, the whole point of this is to overwrite that element with a value. So this is actually pretty interesting, and the next step, just to show how this would behave. So the 0th element of list B is the list. So if we overwrite that with the number 99, that will no longer be pointing to that list, but we would still expect A to have the nested list. So if we say A, we see A still has a nested list. Nothing was changed there. Now if we print out B no longer has a nested list. That was overwritten with just the value 99. So that's no longer a pointer to the nested list. It's just the value 99, and that's it, nothing else. So yeah, the difference is over here when we used two indices, we were pointing to a value inside the nested list, whereas over here we were just removing the whole list itself and replacing it with a value. So that's the difference between those two things. All right, now we're going to talk about using an iterator. So remember at the beginning of this video I talked about the reversed function. So not reverse, but reversed with a D. Reversed with a D creates an iterator. This is not to be, a little note, not to be confused with a reverse. So a little bit less straightforward, but you might prefer doing this. You can use this function to create an iterator and then loop over it. This doesn't really give you a new list though. It just prints the elements in reverse order. So this is just an iterator that uses the original list and cycles over them in reverse order. So let's give this a shot. Yeah, most of the time you won't want to do things this way, but let's just see. Let's paste this in here. Now we're resetting this. We're assigning a brand new list to the list1 variable, list1. So all that other crazy stuff we did to the list is all gone. We have a fresh brand new list. And now let's loop over this list using an iterator. So an iterator is just something you can just loop over. So paste this in here, and yeah, this is kind of interesting using a for loop directly on the command line like this, but and my indentation was wrong. All right, no problem. Usually for something, if I'm doing something elaborate enough to have a loop, I'm usually just going to create a script, but not today. Anyway, let's see how this works. All right, boom, there we go. Reverse order, printed out. It just looped over it and printed each one out in reverse order, exactly as we would expect it from this little code snippet here. So there you go. Nothing too surprising there. It did what it's supposed to. So printed the output. The printed output of the reversed function just returns the memory address of the iterator, so that isn't what we want by itself either. So yeah, let's take a look at this and talk about what it's doing. So if you call reversed, this just returns an iterator. So whatever is returned is just printed out when you're running through the Python interpreter directly like this. So there we go. It just gives you the memory address of the object for this iterator itself. So and you could even assign that to a variable, like do something like this, equals reversed, then ASDF. Yeah, that's all it is. So you can create a variable which is just a string holding this value. I believe that would be a string, or well, let's see, just to see. Type. Yep. It's a class, so it looks like we assigned the iterator to this. We didn't assign. Yeah, I don't know why I'm thinking that would be a string containing the. Yeah. Anyways, it just assigns the iterator to this variable right here, and when we print that out, it just gives you the memory address of that. But the type is a class. All right. So moving right along here. We can pass this iterator to a list constructor, creating a new list. This works great. It's a little elaborate, but you can do it. So let's create a new list called list2. Now this already exists, but we're just going to overwrite it. So copy this. So now we can take our iterator that we created, and we're going to pass this as a parameter to the reversed function. And sorry, we're passing our original list to the reversed function, which will return an iterator, which is then passed to this list constructor, which constructs a brand new list. This is an alternate way of creating a list, is to use the list constructor, and we're going to save that in a new variable called list2, which will be of type list. So enter that and say list2, and there we have our desired result, 9 through 1, so we have the list in reverse. And just in case you're curious, we'll run type on list2, and it is in fact a list, not an iterator. So it says, yeah, class list, whereas over here is class list reverse iterator. So there you go. That's pretty much what that is. Another alternate way to do this would be to use a list comprehension. List comprehensions are always fun. You should understand how to do these, just because it's a nice feature in Python that can save you some coding and make your code nice and compact and easy to understand. You might say, well, how is list comprehension easier to understand than just writing the whole thing out? But yeah, generally it's just more compact, so you can see the flow of the entire program a little bit more easily. That's why it's nice to have compact code. And a lot of times other people there's a great, even if you don't use list comprehensions, other people will use them in their code, so you kind of want to know what they're doing too. You want to be able to understand what other people have written. Plus, it's a good interview question, and it's great for tests. So if you want to know it for that purpose, you should know about list comprehensions. Anyways, you can reverse a list with, here we're using the iterator in a list comprehension. So let's just show how that works. There we go. So for x in this iterator, we're going to return x and print it out. Basically, that's basically the idea of what it's doing. And I have a syntax error, which I did something. Which this should have been tested before the video, but let me see what I can do with this. Yeah, because I'm using Python 3. Yeah, so this would be a Python. I believe that's where I'm going wrong. So this would have been tested with Python 2, and you can just say print like that. I'm pretty sure that's where I'm going wrong here. And there we go. Yeah, so it's a Python 2 versus a Python 3 thing, which I guess that's like a hidden thing that you could get tripped up on. I should probably just use, I should probably write this to Python. I should probably get this updated for Python 3. Yeah, but anyways, you can't just say print in Python 3. You actually need the parentheses. Let's see, doing it the hard way from scratch. This is probably the most interesting thing we'll cover today. So let's read what I wrote here. If you don't want to use any built-in functions or features, you can build your own function to reverse a list from scratch. This is a common use case for exam questions and interview questions. So you might want to know this just because it'll help you with exam questions and interview questions. And in a lot of times interviews will be coding interviews where they want you to solve problems like this. If it's easy, they'll just tell you to reverse a list by hand without using any API functions or anything. If it's hard, it might be like a modified version of this where you have to reverse a list and then add a bunch of logic to do other things to the list. But understanding this step of the process will make those more complicated questions a little bit easier. So it's a good type of thing to know how to do. It's also great if you just happen to want to play around with algorithms. If you really just want to get stuff done, this isn't the way to go. Yeah, that's pretty much true. That's if you really just want to solve the problem, just use the reverse function or a slice. I'd probably just use a slice myself. Anyways, here's our first example from scratch. It creates a new empty list, the same size as the original. It then loops through the original, saving values to the new list, starting at the end of the new list. Finally, it returns the new list. All right, so that's interesting. I'm going to get out of here. List test. Yeah, all right, that's fine. Let's see here. There we go. This is better anyways with syntax highlighting. And there we go, it works. So I was typoing something, and I probably could have taken a few more seconds to figure out what, but there we go. Yep, basically just copied, pasted my code into a file, then ran it. What else? I probably should have just worked through the algorithm for it and got it to work, but anyways, let's do another example. So let's move this over, and actually I'm not sure if this window was out of the way while I was reading through this, but anyways, here's our second example from scratch. Modifies the original list in place. It basically moves through the list from each end, swapping elements. By the time it hits the center of the list, it will only have had to cycle through the list half the number of elements in the list. So, yeah, this is another approach to the same problem, just a different algorithm. What would I call this? Test 2? Yeah, test 1 and test 2. So I'm going to modify that same script and just add a test 2 in there. So edit this script. Right after that first function definition, add another function definition. And there we go. Let's test 2. So what we're doing here, we have two alternate functions that do the same thing. Both of them reverse the list. The code for both of these is great. And if you scroll down here, we see we define our list in order 1 through 9. Then we print out the results of using test 1 and print out the results of using test 2. So we can see that both of these algorithms will work. Let's give this a try. Python 3 test, and there we go. They both work. They both give identical output. So that's pretty much it. Let's actually print list 1 before we do this too. Print list 1, just to be complete, I guess. And grab this line, put it after there. So before each of these, we're going to print list 1 just to make sure it doesn't get edited in place, just so we can see. And there we go. Here's list 1 in order, list 1 reversed, list 1 in order, and list 1 reversed. So there we go. That's pretty much everything. Everything that I can say about Python reverse lists. So reversing a list in Python. That's pretty much, we've covered everything today. So if you found this video useful, just click like and subscribe for more videos like this video.